Well, hello, friends. Welcome back to Commute Talk. It's raining here and really gray, but I don't care because I'm going to be indoors all day. I just have to get to work. Anyways, today we're going to take another viewer question. This time it's from Knob890, who's asking about template metaprogramming and how do I feel about that as a concept, and how do I feel about its use in C++. So I'll say that I love templates, love them. That's the short answer, but let's go for the long answer. So I very often find myself with the desire to repeat something over and over with different data types. And I guess the best example of that is containers. So like, I want to have a dynamically expanding vector of strings. And now I want one that has integers. And now I want one that has this other struct. Being able to write a generic container data structure that just takes a type T and does the most efficient thing possible to store those based on compile time available type information, that's just super freaking neat. And I love that I can repeat myself in C++, not by like making a preprocessor macro to internally copy paste whatever I want repeated, but instead by teaching the compiler how to repeat itself on my behalf. I think that's a tremendously powerful tool, and it's one of the top two features of C++ for me. And like, it's what makes me use C++ over C any day, because and the other top two feature is constructors and destructors, by the way. It's just so extremely useful to be able to do generic programming with templates. And I really love what happened with constexpr being added to the language, because now I can use constexpr stuff and if constexpr, where I previously had to do tricks. I now have tools instead, and I really, really, really prefer tools over tricks. And maybe you've seen like these people who do crazy templates, like check it out, I implemented Tetris in a template that fits on a business card. That type of thing exists, right? And it's not something that ever seemed useful to me, so I never really learned about it. But I knew that things were possible. But with the addition of constexpr and I guess my favorite part of constexpr, which is if constexpr, you can now do a lot of things quite easily that used to require a lot of fuck-aroundery and finesse. I mean, just something really simple, like say that you have a templated function that has a type T, and you want to do something differently based on the size of that type. Now then you would like branch on the size of T, and previously you would rely on the compiler optimizing out whatever code was not needed. But now, because you have constexpr, then you can say if constexpr size of T is this, then the compiler at compile time can prune the untaken branches, and you can do stuff in those untaken branches that you couldn't before, which is really neat. And I guess static assert goes in that bucket as well. But anyways, I'm really happy with templates these days and how constexpr has elevated template metaprogramming for me by like just injecting these subtle little tools into the mix that make it possible to do more stuff, or easier to do more stuff. Let's see, I have to drive correctly here. So yeah, I really, really like templates, I guess. I wrote a lot of custom template containers for Serenity. We have vectors, queues, lists, hash tables, these type of things. And I think they're really, I mean, I'm biased, obviously, but I think they're really pleasant to work with. They generate really small and tidy code. They're reasonably fast. And I don't know. It's just so nice that you can repeat yourself without repeating yourself. You can repeat yourself in an elegant way. Like, what's not to love about that? I guess that's what I think about that. Yeah, I love templates. I love template metaprogramming, but tools, not tricks. So I'm using it to build containers and to implement like fast paths. If I can do something very, very efficiently with some information, with some additional information, but like it's basically the same algorithm, then I can instantiate multiple copies of that algorithm with like a little tweak made based on some information, and then I can choose which instantiation of that algorithm to take based on like a single branch at compile time. So an example of that is like in bitmap scaling in Serenity, where we have this fast path for if you're scaling a bitmap up, like you're drawing a scaled bitmap at 2x or like an integer scale factor, then a lot of the things become a lot simpler because, you know, if you're scaling something up 2x, then you just need to draw every pixel twice. And it's simpler than like scaling something up 2.5x. So we have like there's a templated algorithm for that does better if you know ahead of time what the scale factors are. That type of stuff. I love that type of stuff. Anyways, I guess that's my answer to that. So, what do you think about template metaprogramming? Do you like it? Use it a lot? Do you have something against it? Do you prefer preprocessor macros? I guess I would love to hear about why someone would prefer preprocessor macros over templates. So that's interesting. Yeah, so I guess I'm out of things to say here, so I'm just going to say thanks for hanging out with me on the commute and for sending in questions. I really appreciate the questions. Keep them coming. And I will see you guys next time. Bye.